Relation between scales, different temperature measuring scales. Already we discussed in our last session about different scales. The general formula I told you that for any scale, if you take the scale reading minus lower fixed point, LFP is lower fixed point by upper fixed point minus lower fixed point is constant. This is the information already we noticed. So for any scale, this is the general formula for any scale. For any scale, if you take the scale minus lower fixed point by upper fixed point minus lower fixed point is constant. In last class, we discussed about Celsius scale, Fahrenheit scale, Kelvin scale, Raman scale, Rankine scale, and faulty scale, like that. Now we'll compare all those things. First, let me take the Celsius scale. So let me take the Celsius scale means first let me take a term C. C means here indicating Celsius scale. What is the lower fixed point in the Celsius scale? 0. Upper fixed point in the Celsius scale, what we have, upper fixed point means 100, lower fixed point 0. So this is for Celsius scale. And if I take the Fahrenheit scale, I can write the scale name as F minus lower fixed point as 32 and upper fixed point also we know that is 212 and again minus 32. From this formula, where you are doing this one, sir, means scale I am putting here, this is lower fixed point, in denominator upper minus lower. Upper fixed point for Fahrenheit thermometer 212 and lower fixed point 32, and for Celsius upper is 100 and lower is 0. Now coming to next one about Kelvin scale. Kelvin scale, lower fixed point 273.15 by upper fixed point, I can write it as 373.15 minus 273.15. So this is the first one is Celsius scale, second one Fahrenheit scale, third one Kelvin scale. Now let us equate the remaining scales also. Now Raman scale, I am taking Raman scale, there is nothing but R minus Raman scale, I am writing it as R minus 0 by upper fixed point I am taking it as 80 and lower fixed point as 0. So in a Raman scale, R minus 0 by 80 minus 0 is equal to now Rankine scale. In Rankine scale, the lower fixed point is already I discussed with you, that's a 492 by upper fixed point 672 minus 492. Finally, let me equate to some error scale. I'm calling it as a faulty scale. In my last session, I explained you about faulty scale also. So Z is any scale. For faulty scale, I am representing Z is the scale reading minus lower fixed point is X and divided by upper fixed point is Y and lower fixed point is X. Z minus X by Y minus X. That's the relation between the scales. I hope you are clear about these different scales I have taken. What is the first scale? First scale is nothing but Celsius scale. Let me simply call it as Celsius scale. This is, let me write also here the names for this scale. So this is a Celsius scale, and this one name I can write it as a Fahrenheit scale. Let me write the name this one for as a Fahrenheit scale. Next one, what is the scale name? Next scale name is Kelvin scale. Next one is Kelvin scale or absolute scale. We can also call it as Kelvin scale or absolute scale. Next one, this one has a Raman scale, that is a REAUMUR Raman scale. And next one, let me write this scale name as Rankine scale. Rankine, Rankine scale, Rankine scale. This is Rankine scale. Last one is error scale, that I am calling it as faulty scale. I am calling it as faulty scale. Faulty scale, faulty scale. This is error scale. So if I want to do some problem related to one conversion from centigrade to Fahrenheit, like that, centigrade to Fahrenheit, or Fahrenheit to Kelvin, or Fahrenheit to Roman, or Fahrenheit to Rankine, Celsius to Rankine, you have to equate those two. Suppose Celsius and Fahrenheit, I want to do conversions, equate these two, take these two. And suppose Celsius and Kelvin, take these two. Celsius and Roman, take these two. According to the situation of the question, you have to select and you have to do. For example, to this one, I'll take one problem here, I will discuss. They are telling that simple problem, I'll take one simple problem. Convert minus 10 degrees centigrade. Convert minus 10 degrees centigrade into Fahrenheit scale. Fine, convert minus 10 degrees centigrade into Fahrenheit scale, they are asking. How to convert? Just now we told the formula as C minus 0 by 100 minus 0 is equal to Fahrenheit scale. They are asking to convert into what scale? Fahrenheit scale. Fahrenheit scale. So you must not forget that what is the lower and upper fixed point of each scale. Then everything is simple actually here. So I can write this one as a f minus 32 by 212 minus 32 I can write, and from this one I can write now c by 5 is equal to f minus 32 by 9. How you got this one, sir? Nothing here. Actually 100 is there and here 180 is there. You observe here carefully. Here denominator 100, here 212 minus 32 is 180. If I cancel here 5 and 9, so simply I can write here 5 and 9, c by 5 and f minus 32 by 9. So they have given us c value as minus 10. C value as minus 10. So from here, what is the f value? F value I can write cross multiplying. I can write 9c by 5 plus 32. Simply c value they mentioned as minus 10. Substitute here 9 by 5 into minus 10 plus 32. So here now that means you'll get minus 18 plus 32. Minus 18 plus 32 means I can write it as 14 degree Fahrenheit. 14 degree Fahrenheit. Very simple problem. That means when they are asking to centigrade to Fahrenheit, immediately what I took here, I already just now I gave the different scales relation. As they ask centigrade and Fahrenheit, I equated these two things. I equated these two things now. Just equated these two things. C value they mentioned, C value substituted, I got the value of F. That's the method I followed here. I hope you are clear with this one now. Let us see the next one. Now, small question they are asking like that. Some small example problem it is also they show that minus 40 degree measure the same temperature on Celsius scale and Fahrenheit, it measures same they are asking. That means generally the readings when you are observing, some value will coincide in the two scales. What is the value which coincide on the Celsius scale and Fahrenheit scale means that's minus 40. Let us check it out. How you got minus 40? This actually I want to do the proof for this one. So here the problem is the relation between Celsius and Fahrenheit. Just now I have given you that is a C minus 0 by 100 minus 0 is equal to, I can write it as F minus 32 by 212 minus 32. And for more precisely I told you that, the denominator, instead of doing all these things, I can write this is 5 and this is a 9, and even you can write it. So whenever Celsius and Fahrenheit is given, now onwards your mind has to say that C by 5 is equal to F minus 32 by 9. This is a relation we can write. No need to write the total data here. That means writing C minus 0 by 100 minus 0 equal to F minus 32 by 212 minus 32. No need to write the total here. Simply here 100, here 212 minus 30, 180. Anyhow, it goes in 5 times and 9 times with 20. So 5, 9 in the denominators. So from now onwards, you please don't worry about that and simply put C by 5 is equal to F minus 32 by 9. Fine. Now they told that at what temperature, that means they are measuring the same temperature. Let us, for to prove this one, let us take, let C and F both are equal to same value. We don't know the value. Let us think we don't know. They have given here minus 40, but let us think now we don't know that value and we are going to find. So the unknown quantity, I am naming it as X. Let, this is let, we are naming it as X. Our target is to find the X value here. So let me take here X by 5 is equal to X minus 32 by 9. So now we can just cross multiply and simplify here, then what will happen here? So I am getting it as 9x is equal to 5x minus 32 into 5 is nothing but 160, and 9x minus 5x means 4x is equal to minus 160 means obviously x is minus 40. X is minus 40 I got here, x is minus 40. See, there is a question actually they are asking to show that minus 40, it measures same temperature on Celsius and Fahrenheit. So in Celsius and Fahrenheit, minus 40 temperature is same, minus 40 temperature is same on the both the scales. That's the thing what we noticed here. I hope you are clear here. What we did is at minus 40 temperature, the Celsius scale, if you take a Celsius scale and on Fahrenheit scale, the temperature is same. Minus 40 temperature is same. Either you take Celsius scale or Fahrenheit scale. Fine. I hope you are clear with this example now. So the question arises, sir, you are telling from that time onwards Celsius and this Fahrenheit only, take another thing, sir. Yes, I will take another thing. Same model example, I will take one more thing. You will be more clear with that one also. So the question is like that. Find temperature for which the reading on Kelvin and Fahrenheit scales. Kelvin and Fahrenheit scale. Kelvin and Fahrenheit scales are same. Fahrenheit scales are same. Almost same, similar model question, right? Your previous question, what we discussed, Celsius and Fahrenheit same, we told in previous question. Observe carefully here. We told Celsius and Fahrenheit same, temperature measures means minus 40. Now the question is Kelvin temperature and Fahrenheit scales. Fine. First of all, what's the relation between those two means already we noticed that if you take this the Fahrenheit temperature and this is a Kelvin, this is the relation. F minus 32 by 212 minus 32 is equal to K minus 273.15 by 373.15 minus 273.15. So this is the relation between them. Let me take this one. Minus 32 by 212 minus 32 is equal to, there is nothing but K minus 273.15 by 373.15 minus 273.15. So let me write like this. So they are telling that F minus 32 by 212 minus 32 is equal to K minus 273.5 by 373.15 minus 273.15. Fine, what is 373.15 minus 273.15? Nothing but 100. Nothing but 100. What is 212 minus 32? Nothing but 180. So now, if I cancel again with 20, 25 and 9. Same in Celsius and here also same no beta, and Celsius scale and here also. Let me write here. Now, here in denominator in Celsius scale also we got there 5 and Fahrenheit 9 in there also. Just notice denominators. I'm not talking about numerators. I'm talking about the denominators here. That is as 5 here for Celsius. You can notice here we can notice 9. We can notice here 5 and 9. No, here also we got the same. Because here also difference is 100 in the denominator for Kelvin. Kelvin formula in the denominator you can find the difference is 100. So I can write like that now. Fine. Now what is the formula I can write? Means what I need here, they must measure same. They must measure same means what is the process we have to take. Let f and k both are equal to what I'm taking x. I'm just taking the term x, both are equal to x. And I'm substituting that x minus 32 by 9 is equal to x minus 273.15 by 5. I think you can do the cross multiplication. 6 degree Fahrenheit. Both are equal. 574.6 Kelvin is equal to 574.6 degree Fahrenheit. That is my conclusion for this problem. I hope you are clear till here. I hope you are clear. So that means when we notice in Celsius and Fahrenheit, what temperature both measures same means we got it as minus 40 where Celsius and Fahrenheit measures same. Now what we notice here is what is this one Celsius and sorry not Celsius, it is a Kelvin and Fahrenheit means is a 574.6. I hope you are clear with this problem now. Okay then. Next. Sir, you told something like the term faulty thermometer, sir. Faulty thermometer you are using. Can you give some example problem related to faulty thermometer? Definitely, I will give one example. Check it out now. A faulty thermometer, they are telling like that. A faulty thermometer has its fixed points, notice carefully this problem, fixed points as 5 degree and 95 degree, 5 degree and 95 degree. These are the fixed points on where faulty thermometer. Sir, you told fixed point, but you didn't told upper and lower, sir. Why to tell again upper and lower? Which is small is called lower fixed point, which is big is called upper fixed point. That's all. So no need to inform lower and upper. Just small one is lower and big one is called as upper fixed point. Fine. What the question then? What's the question here? The temperature of the body, the temperature of a body as measured, the temperature of the body as measured, they are telling that the temperature of the body measured by faulty thermometer is 59 degree. Find the correct temperature. This is actually faulty itself is saying something error, right? So they're asking us to find the correct temperature. Find the correct temperature of the body on Celsius scale. They can ask on any scale, that depends on the options. According to that means suppose objective exam, according to the options you have to decide. Now directly it is not an objective exam, I am explaining you. I have given find the correct temperature of the body on Celsius scale. I mentioned the scale name also, but generally what we'll do, we'll find it Celsius or Fahrenheit. What we have to do, we'll understand by observing options, in the competitive exams, because objective exams, by observing options we have to decide. No problem at all. I only mentioned it is what scale, Celsius scale. Correct temperature, what they want here, correct temperature of the body on Celsius scale. The reading what they noticed here, the reading what they noticed 59 degree on faulty thermometer, and the data is given that lower fixed point is F and upper fixed point is 95. Let us take this data and put it in one formula. First of all, let us check the formula. So Celsius scale, C minus 0 by 100 minus 0. Faulty scale, Z minus X by Y minus X. X is called lower fixed point, Y is called upper fixed point, Z is faulty thermometer reading, faulty scale reading, not thermometer, faulty scale reading. Fine, I hope you are clear till here. Now, Let's go back. This faulty thermometer reading I am taking it as Z. Next, let me write that formula here. That is a C minus 0 by 100 minus 0 is equal to F minus 32. Sorry, not F, right? It's a faulty thermometer. Again, we must not write F, and it's the faulty thermometer means my formula is Z minus X by Y minus X. So from the given data, what is the X value, what is the Y value, and what is the X value means here X is 5, Y is 95, Z is 59. Observe carefully, X is 5, lower fixed point, Y is upper fixed point 99, Z is the reading on the faulty thermometer 59. So 5, 95 and 59, let me put the data here. So I want the value of X, that is 5, and Y, the value is 95. And the Z value, what we notice, Z value is equal to 59. And now what we want to find, the correct value, that is C, correct value of C. Very simple then, C by 100 is equal to Z is 59 minus 5 by 95 minus 5, then we'll get the value of C. We'll get the value of C here. That's all. This is a direct problem you can solve, and finally we'll get the answer if you solve this one. Approximately we'll think 60 degrees centigrade, I think you get approximately 60 degrees centigrade you may get. If you just solve that one, cross multiply and simplify, you will get nearly 60 degrees centigrade, So I hope you are clear how to handle this type of problems for Celsius and Fahrenheit scale. So not Celsius, Fahrenheit we discussed, Kelvin and Fahrenheit we discussed, and faulty and Celsius we discussed. So relation between the scales, how to handle the problems I explained here. So this is the first page where we discuss the formula here for relation between all the scales like this. And I want to make little more short the formula relations. I want to give one more information here. Let us concentrate on this one. Very important point I am going to give. Very important means those formulae only, just I want to make more simplified. So I can write that C by 5 is equal to F minus 32 by 9, R by 4, RA minus 492 by 9, and K minus faulty thermometer not required. Let me write here 9, and K minus 273.15 by 3 by again 5. So like that we can make simplified. Actually nothing I did here. What I did here means I have taken all these denominators. So here denominator 100, 180, 100. Here you observe this is 100 denominator. 212 minus 32, 180. Here 100. Here 80. Here 180. Okay, leave faulty scale. Here 180. So making simplification of this one, denominators, all the things, if you cancel like that, we are left with like this. So what we have, so little K minus 270.5 is not looking little good. Let me write here otherwise. C by 5, here let me write here. C by 5, let me write here last centigrade, and let me write here K value, K minus 273.15 by 5. So Kelvin scale, Fahrenheit scale, that means no need to take always a 212 minus 32 and all those stuff not required. This because when you are solving the problems, you have to take every time here 100 minus 0, 212 minus 32, these are like that, not necessary. Simplified. Now I simplified that formula and I wrote like this. So K minus 273.515 for this is a Kelvin scale, and this is now what we are comparing. This one is a Fahrenheit scale. Just 1 minute here. Fahrenheit scale I have to write. Next I have to write this is a Reaumur scale. This is Reaumur scale I am writing. Reaumur scale, and this is a Rankine scale. And last one is a Celsius scale. Like that I have written all the scales. Denominators I just cancel the common terms in the denominator, and finally I got this stuff. I hope you are clear till here about the relation between Kelvin scale, Fahrenheit scale, Reaumur scale, Rankine scale and Celsius scale. And more precisely, suppose I want not a temperature, that means not particular temperature, difference in temperature, I can write delta K by 5, delta F by 9. Whenever they are asking to compare the relation between difference in temperatures, then I can write delta R by 4. This is delta RA by 9, delta RA by 9. This is delta C by 5. They are comparing the differences. Just you can take like this formula. This formula is for here delta K is difference in Kelvin temperature, difference in Fahrenheit, difference in Raman, difference in Rankine, difference in centigrade. When we are comparing differences, you no need to like take like this K minus 273.5, F minus 32, like that, no need to write. Simply you can write delta K, delta F when difference is mentioned. Difference means increase or decrease. In the question, they will mention that increase in Fahrenheit thermometer is given. Find the increase in Kelvin. Then no need to use this formula. Increase in Fahrenheit, increase in Kelvin comparison. Mean directly you take this formula. When should we take this one? If Fahrenheit value is given, direct Fahrenheit temperature value, one particular temperature value, and they are asking Kelvin, we will select this formula. But if they are given that the increase in Fahrenheit or decrease in Fahrenheit, that is nothing but delta F. Then we no need to use this formula. Simply you can use this one. Delta K by F is equal to delta F by 9. Here you will get delta K is nothing but that increase or decrease related to the Kelvin. So according to the situation. So this last one also you have to be alert. Whenever they mention increase or decrease in the question, you must not be hurried to take this formula. Increase or decrease or some change means you have to use this formula. And simply the particular temperature they are mentioning, then you have to use this above formula. I hope you are clear with these things now. So this is the base information about the scales of Kelvin, Fahrenheit and Raman, Rankine and Celsius, and how to handle the problems and everything I explained you. I think this topic is clear.